Hello space fans and welcome to another edition of Space Fan News. This week, astronomers using the Atacama Large Millimeter Submillimeter Telescope have a cosmic weather event that has never been seen before. Astronomers map 1.2 million galaxies to get an idea of where all the dark energy in the universe is, and a quick update on NASA's Juno, New Horizons, and Dawn missions. This time of year is usually pretty quiet with new astronomy announcements, so I thought I'd take this week to report on some earlier, very interesting news stories that caught my eye, but didn't make it into previous episodes. First up, on June 8th, astronomers using ALMA, the Atacama Large Millimeter Submillimeter Array Telescope in Chile, observed towering intergalactic gas clouds falling in on a supermassive black hole at the center of an elliptical galaxy 1 billion light years away. In past episodes, I've told you a little about how astronomers think supermassive black holes are born, feed, and grow. And one is by accretion, where material falls in from gas clouds, stars, and other black holes, and anything else unlucky enough to get too close. And the other way is this new thing astronomers are calling direct collapse, which I told you about in SFN 170, where a whole lot of gas and material falls in on itself so fast that it skips making the star stage altogether and goes straight into forming a supermassive black hole. Well, the process observed by ALMA was the first one, accretion, and is the first direct observations that show that cold, dense clouds can form from hot intergalactic gas and plunge straight into the heart of a galaxy. In the past, under the process of accretion, astronomers believed that supermassive black holes fed on hot ionized gas from the surrounding halo of material around the galaxy. These new ALMA observations show that under the right conditions, black holes can also feed on these giant, clumpy clouds of cold, intergalactic molecular gas. You can imagine what's going on by thinking of how warm, humid air on Earth can condense and create rain clouds and precipitation. Something like this is what astronomers think is going on at the center of this elliptical galaxy, which is the brightest in the Abell 2597 galaxy cluster, some 1 billion light years away. Near the center of this galaxy, astronomers observed 3 huge clumps of cold gas falling in towards the galaxy's core at roughly 1,000,000 kilometers per hour, with each clump containing as much material as 1,000,000 suns and measuring tens of light years across. Additional observations taken by the Very Long Baseline Array, which consists of 10 identical antennas located across the Earth, show that these gas clouds observed by ALMA are only about 300 light years from the central black hole, which means they are essentially on the edge of being devoured. While ALMA only saw 3 clumps falling in, astronomers think there may be thousands more they can't see also on their way in, providing food for this supermassive black hole lying at the center of one of the largest galaxies in the universe for a very, very long time. Next, the largest 3D map of the universe ever taken that contains the positions of over 1.2 million galaxies has allowed astronomers to make one of the most precise measurements yet of dark energy, that elusive stuff that many think is the cause of the acceleration of the universe. Mapping dark energy throughout the universe became a priority for cosmologists when it was discovered that the universe is not only expanding, but accelerating as it did so. For the universe to accelerate as it expands, it requires a force, and that force they are associating with an inconveniently named thing called dark energy. Hundreds of scientists from the Sloan Digital Sky Survey 3 project collaborated to make the maps and uses something called baryon acoustic oscillations to look at the expansion rate of the universe's density pressure waves traveling through the universe. Now, these pressure waves are called acoustic because these density waves are measured as if they're sound waves. These waves have left an imprint on the cosmic microwave background from the Big Bang that astronomers can compare with the pressure waves they are measuring with the Sloan instruments to see how they shape the cosmos over time. What they report is that they see a dramatic connection between the sound wave imprints left over from the Big Bang when the universe was only 400,000 years old, to the clustering of galaxies they see later, some 7 to 12 billion years later. This map is invaluable in getting an idea of the density of dark energy over all the parts of the universe that were seen by this survey, along with the distribution of all the dark energy throughout the universe. There's another project called the Dark Energy Survey, which is also expanding this research by looking at 5,000 square degrees of sky over 525 nights to try and characterize these same properties of dark energy, all in an attempt to try and figure out where it is, how it behaves, and most importantly, what it is. Finally, many of you have asked about the status of NASA's Juno mission to Jupiter. It arrived at Jupiter on schedule on July 4th, but since then, it's been pretty quiet. Well, I was wondering about this silence too, because NASA is anything but shy when a mission that it's running approaches a planet. So I started asking around about this some more, about when we might expect some more images from the spacecraft. Upon arrival, Juno took a bunch of images using the onboard JunoCam, but right now it is busy getting itself situated in a polar orbit I've told you about many times. Juno was expected to orbit Jupiter 37 times, getting as close as 4,100 kilometers from the cloud tops. So right now it's working on getting it positioned into that orbit, and the first high-resolution images are expected on August 27th, and NASA is currently working to make sure all images and data will be available from the mission website. I will keep you posted. Also, here's a couple of small announcements. Back on July 1st, NASA's New Horizons mission was given the approval by NASA for its next phase, a flyby of a Kuiper Belt object. Using data from Hubble, several candidates were offered up, and the object known as 2014 MU69 was selected as the target KBO. The New Horizons spacecraft is scheduled to arrive there on January 1st, 2019. Also, in addition to the extension of the New Horizons mission, NASA determined that the Dawn spacecraft should remain where it is, at the dwarf planet Ceres, instead of changing course to the main asteroid belt at Iona, which it was going to do, but they decided to leave it where it was. So Dawn will continue orbiting Ceres, taking data and sending it home until it can no longer do that. Well, that is it for this week, space fans. A quick programming note, I am off next week on vacation, so I won't be able to make an episode of SFM, but I will return the following Friday. I want to thank also a very special thank you to Daniel Torn from the Netherlands, who sent in a very generous donation in support of SFN. Thank you, Daniel, I appreciate it. I want to thank all Patreon patrons for their support in helping make SFN possible. Thank you guys for watching, and as always, keep looking up.